What's coming off around here?
If you guys playing railroad anymore today, there's a landslide, a new cut.
Welcome to episode 4. This is part 3 of saving an antique Athearn SW7 locomotive. It's an HO scale locomotive. The repair and reassembly is currently in process. The motor has been reconditioned, cleaned, and reassembled. So it's now necessary to reinstall the motor into its frame. To do that, the motor mounts that are broken have to be replaced. I've proposed at the end of episode 3 that I would replace this motor mount, these motor mounts, there are 2 of them, with plastic replicas that I'll be making from plastic structure material. What we see here is the broken motor mount that I had the luck of retrieving. It actually is fairly intact. And you can see that just by inspection that the largest portion of this motor mount, the top and the side and the bottom, had the same width. So for the material that we're going to build these pieces out of, I need all of the pieces that I cut out of here to be this width. So just putting my divider on that, I can scribe a mark on the plastic, and the mark is going to be an indicator of the amount of the plastic to cut away to be able to make the pieces. I need enough of these for 2 motor mounts, but I might as well try to make 3 just in case one of them is a total disaster. So what I've done is I've attached the plastic that I want to cut to size onto my cutting board, and I trued it up to the line in the cutting board right along here, and I placed my right triangle in the approximate width. It's a little bit wider than what the actual part needs, so I'll trim that back down if necessary, and I'll cut along the triangle with my hobby knife. So we'll make a couple of the slices along that line. Let's make sure it's square, and then I'll make the a light cut down along here. There's one. Now that should just snap. So I nipped off a small piece of the plastic, this larger piece of plastic that I sliced off. And this small bit is ostensibly the same size as the flat portion of the motor mount. However, after close examination of the motor mount, I've discovered that, in fact, right here, I think you can see it, there's actually a ridge here, and that the side beneath the cylindrical portion is narrower than the side up on the top. So what that means is that I'll have to trim that piece for here smaller than the piece that will take the place of the top. But in addition, I wanted to show that I found that the bottom piece, this is actually not broken. This is the way it was made. And it's not flat. It's flat only to about halfway, and then it tapers up. So that piece is a lot more complicated than just cutting a small flat piece. Now the reason for that, it pertains to the motor itself, where this motor, the motor shell actually curves down where the motor mounts fit into this space here. So the curving was done in order to fit it up against that shell. So my goal, immediate goal, is to try to make the bottom piece of this motor mount. And the motor mount bottom turns out to be nearly twice as thick as the top part of it. Well, we're calling top and bottoms here. I'm sorry. That's nonsense because its orientation is this. The cylindrical part faces down into the frame of the locomotive. But just for the sake of discussion, we'll call it top and bottom, and I'm calling this bottom. And I'm saying that it's thick enough where I've actually snipped out 4 individual pieces of approximately that outside dimension. And I'm going to glue 2 of them together and 2 together to make the thickness of this bottom piece. And once that's glued together, I'm going to use my file, and I'm going to file in that bevel that we just discussed regarding the motor, the rounding of the motor. So I've got glue, and I'm hoping that this will work on this plastic. I'll tell you what, we'll find out. Okay, now I have the pieces bonded, in the process of bonding together, and the next step is to cut the bevel into them. So I have the replication of the bottom of this motor mount. Okay, so the 2 motor mount bottom halves is what I'm calling bottom halves right now, have been made, and they match this portion of the top, just that portion of the motor mount, and you can see the bevel that we just discussed. It was put there for it to fit up against the motor. And so if you look at these, both are pretty much identical. So of course it's difficult to pick up, but here's the bevel that was put onto the combined pieces of plastic. They're welded together, and they've been cut with a hobby knife to, replicate the bevel that was on the original motor mount. So that piece is, the 2 pieces are finished. And according to rule number 13 of the Boomer diorama do's and don'ts, I made spare pieces just in case, but it looks like these 2 pieces that I made here are going to work just fine. So what you see right here are the pieces that I've just cut to size. We've already discussed these 2 pieces. These are the beveled edge pieces that simulate this, what I'm calling a bottom. There's 2 pieces here that are for the tops. That would be this portion, the back then of the Motor mount is simulated by these two pieces right here. And this center brace is these two pieces here. And this has to get doubled. The brace itself is twice the thickness. It's similar to the bottom piece. It's twice the thickness of the plastic material. So these two will get glued together. These two will get glued together. And they will become the centerpiece. The backs will get joined to these beveled edges to simulate the assembly of the back and then the bevel this way. And then on that will be placed the assembled center brace, and then on the tops will then get placed on top. So that should be able to construct everything for the motor mount except for the cylindrical portion, which will come next. Here I've mounted the assemblies of the motor mounts onto the motor just for test fitting purposes, and they appear to be fitting quite fine. I didn't bother videotaping the process of actually cutting or welding these pieces together because they're very small pieces. You just can't manipulate that and photograph it at the same time. And it was a tedious process that just required a lot of repetition because the parts kept falling out of my fingers. I got big fat fingers, I guess, and this is just a challenge to be able to manipulate them in the correct positions. But they do fit fine. So the next step in the process is the addition of the actual cylindrical portions on well, let's just call it the top for now. It's like I said earlier, it's not possible to distinguish top and bottom at this stage, but we'll have to cut and assemble and install the cylindrical portions next. So what I've done is I've created two of these fairly small inserts, this tiny thing, that go, they'll be inserted inside of the frame. This one I have already inserted here, and the other will go into this position here. And what I have to do then is to put some cement on the surface of the insert and then install this assembly, the motor mount assembly that I've been making, and I'll put some of the weld in a position, well, I guess it would go this way, and then I will put some weld on the assembly in the same position that the insert's at, and then I'm going to apply some pressure from behind and above to hopefully hold the two pieces together, and by doing that, my expectation is to weld the inserts onto the assemblies in the correct, precise position. So let's see how that works out. So what I've ended up with, having done the welding, is that the inserts are attached and hopefully are in the precise, correct positions. And because there may be some small, slight difference between them, I've marked the one that it goes into here with a small pencil mark so I can differentiate them. The final assembly, when I actually install these into the motor to mount the motor in the frame, I'm going to use, I have trouble picking them up, they're so tiny. I'm going to use these tiny screws to attach these to the frame. And hopefully it's going to work, but nothing's a given. So I just, until I finally give this a chance to cure and I get a chance to assemble the rest of the motor and try to install it, well, I guess that's the point when I'll find out for sure whether or not my plan to use screws to mount the motor is going to work out. Let's find out. Moving on, the next step to the reassembly is going to have to be the repair of these trucks. These are the side frames, the 4 side frames from the 2 trucks. And there were 2 things I wanted to point out at this point. One is that earlier disassembling the truck, I managed to break a piece of this plastic portion off here. So that has to get bonded back on. Hopefully that will bond successfully. And the other thing I wanted to point out is that these metal pieces are important to the motor because they conduct the voltage and current from the side frame up through these metal pieces. And so they need to be electrically connected to the side frame. And the only one that's still connected is this one right here. That rivet didn't break altogether. And this, interestingly enough, these 2 smaller pieces, they mount this, the way I've shown them, they mount against this upper piece, but they also are oriented, it seems, that they each point towards one another. And I thought that interesting. I didn't notice that until just recently when I was messing around with these parts. Anyway, moving forward, I'm going to try to repair the plastic, and then I'm going to come up with some technique where I can electrically bond these pieces together. If you're thinking solder, you got to think again, because these plastic pieces might well be damaged if I apply too much heat to trying to solder these. So I got to think of something. Well, I think I've devised a method for reassembling these conductive these metallic pieces back onto the trucks without damaging the plastic. But the first thing I did was to experiment with the solder. And I put, oh gosh, my fat fingers, gosh, that's hard to grip things. Okay, so back to this. I put some solder on this piece and checked that it would bond, and it actually bonded quite well. So, and all I did was, sand the surface to prep it, and then of course applied a little dab of solder. I didn't want to put too much on there, but that reassures me that I can solder these 2 pieces together. And then my plan is not to solder this to this, because that would mean going through the plastic and destroying the plastic. So what I've decided to do is I'm going to solder a wire to this portion of the truck face, and then I'm going to pull the wire through the plastic hole corresponding to this, assemble that, and epoxy it. I'm going to epoxy that piece together, and the reason being is because these were originally riveted together. I don't believe this was ever intended to be disassembled, and epoxying it is just going to restore the original intent of the design. But once I have the wire pulled through this piece here, I'm going to then, if these 2 pieces are successfully soldered together, I'll pull the wire through the hole that exists in these 2 pieces. I'm going to solder them at the top of this piece here to weld them, and then pull the wire through, and then I'll solder the wire to the smaller piece inside. So that should give me a good electrical conduction between the side piece of the frame for the truck and these electrical conductors. So I now have a plan to repair the damaged side frames, and I will now proceed through that repair process. I'll present a series of videos showing the progress instead of filming the whole thing. I anticipate it to be fairly tedious and time consuming to do it. So let's see how that all turns out. Well, I've completed the assembly up to the point where there's a wire that's been welded to the side frame that's protruding through the plastic, and I've epoxied the metallic parts. After these were soldered together, they were epoxied into the plastic, and epoxy is actually capturing the wire itself coming through. It actually does a very good job of bonding this metallic material to the plastic material. The thing I wanted to demonstrate here is we're going to measure the ohms between the wire and the metallic. And I expect that to be very little. It's 0.3 ohms. And the resistance between the side frame and the metallic is showing 0.1 ohm. So it's not true, to that precision. But what it's saying is that there's effectively a dead short from the side frame to the wire. In addition, I would like to point out that the epoxy has captured this wire encapsulated it onto this metal piece, which makes it an integrable part of this assembly. So here's the two truck side frames that have been reassembled, and as you can see, the broken piece has been reattached. I had to use epoxy because my weld, it's the plastic. I'm about to explain why the assembly thus far has gone wrong and how I plan to fix my mistake. However, even at this point, I don't clearly see the true error. I was too focused on the individual parts and not focused entirely on the total structure. However, this repair I explain in the following segment is the right method to correct the mistake. Well, I've reached a point in the repair and reassembly of the trucks that I've hit upon an issue, and I need to correct that. The issue is simply this. These short conducting pieces that I've assembled onto this plastic and side frames are facing one another. But the assembly requires for the opposing pieces to be married together, to be joined such that the small conducting piece is facing across the top of this small frame flat piece on the opposing side. Clearly, that's not the case here. This one is facing that one, but it's going to hit the gears if it's reassembled. It actually will hit this gear here because it's supposed to be going across the top of this. So, my assumption was that both of the metallic pieces had been riveted to the same side of the truck side frames. Evidently, that was a false assumption, and in fact, in order for this to work now correctly, I have to place this small conductor on the opposite side frame so that it's facing correctly across the top of this flat portion. The process of correcting the mistake and getting the correct orientation for the small metallic piece here, I'm having to remove the gears from this opposing part of the side frame for this truck. These gears had to be removed so that the small conductor can be placed into the correct position. And one of the issues that arises as a result of this is that I need to assure conductivity with this small conductor through the plastic to the metallic part of the side frame. In order to do that previously, what I had to do there was to actually solder in a piece of wire. So as you see on this piece right here where it's been soldered, I have to replicate that same effort here. Well, I managed to repair the side frame and assemble this first truck. We'll find out whether that works correctly or not, but the continuity seems to be fine on the conductive pieces. So it wasn't until after I had assembled that first truck and I was looking at the one with the circle and the red line through it that I realized it would not work, and here's why. What you see in the image are the side frames from the two trucks. The red marks identify the raised part of each truck. The blue dots identify the long conductors, and the green dots identify the short ones. The side frame on the left was just modified to reverse the small conductor. It was removed from here and moved to the opposing side of the frame so that it faces the opposite direction. It does not interfere with the truck's large gear. But notice that the two large conductors are still both facing each other when the trucks are assembled. The role of the short conductor is to transfer voltage from the same rail on one side of the track to the frame. That frame in turn applies that voltage to the bottom of the motor. The role of the long conductors is to transfer voltage from the same rail, but on the other side of the track to the top of the motor. Because the truck side frame on the right has its long conductor pointing inward, the two long conductors are in electrical contact, and I have created a dead short. So I've repaired the two truck side frames. These are the repairs that were made. And had this been on this side of the frame, you can see that the long conductor is here, and this piece goes over the top, and that would have been a short between the two rails of the track. So correcting that was real important. I got a lot of time invested in repairing and re-repairing things, but it seems to be working out. So, given this explanation about the side frames, it's now possible to do the full reassembly of the final truck and install it into the frame. So, to start with, I got to put the gears back onto the side frame here. Make sure I can see that. Get there. There it is. And that last gear fits in there like that. So the next step is to hold these together somewhat. Not entirely, though. I don't want to completely clamp these because I need to get this worm gear back onto that gear, and if they're snapped together it won't fit. So get it in, come on, there we are. So we'll just make sure this is opened up a bit. That should do it. I'll pick up this gear and put that to there. And so the worm gear is in contact with the big gear, and then I place this cap over, if I can pick it up, over the top. This plastic is super slippery, so it should just snap on to the piece. There it is. And the next thing I want to do is place, there's this small clip right here, and place it over the front. There it went. So you can see that the small clip is on the front and the big clip is on the raised portion over the main gear and the worm gear. So the next thing I want to do is place the wheels into the truck, which I do just by a little bit of pressure on the truck side frame to just pull it back a little. Then I can insert the wheel, and then I'll do the same thing on the other side to get the wheel into the cup that it was designed for. So there's one wheel, and get this other one in there, and there we go. There it is. So there they are. With the wheels are now mounted onto the truck. I can place this bottom piece over to cover the gearing, and that should just snap on. Wow, easily. This is essentially complete. The next thing I need to do is to install this into the frame. And, from the original removal, recall that these tabs here on each side of the truck are captured by these raised portions on the frame. So the motor will get pressed into position. Get it in here. And they just snap, and you see that they've captured it. So that one is now in position. So the next thing to do is to mount the motor. So the motor mounts are already on the motor, and it's just a matter of squeezing the motor in. Now in this process, this has to be squeezed in. Both of the trucks have to be facing out to give it room, and that these couples have to be facing inward. And I'll struggle to get that in. This one has to go in. And this one. Where there's one, there will be another. Okay. And again, and in there. Whoop, almost. It keeps hanging up. There it goes. Oh, I thought I had it. Now I do. Okay, so not so simple, but it's done. So the next step is to get the motor mounts to press down into the side frame. So I just encourage them to go down in. A little pressure on this guy. There he goes. All right. So the motor mounts are now pressed in, and you can see the motor mount where the screws are to go, showing through these holes on the bottom of the frame. So I'll now put the screws into it to hold it in place. And there's one. Oops. And the other. And just tighten these. And I think this screwdriver is magnetic. It's not working well. There we go. Turn that one in. Okay, they're both snug. So now the motor is mounted. And the next step in the assembly is to install this upper conductor, which snaps on, but it's got to be underneath these. So I'll raise it up, and then snap it down. There we go. So now you can see that these tall conductors now are shorted together and they're on the same side of the track. The last thing to do as far as insulation is to put in the headlight. It goes in this way. The headlight has to be in contact with the long conductor so that when it swivels, of course, it maintains connection to the headlight, through the headlight, and then back to the frame, which is supplied with power from the short conductors. And that would be through the bottom of the motor. All right, enough done. Let's test it out. All right, I want to close out the assembly of the locomotive. At this point, everything that I set out to repair has been successfully repaired, and everything now is in its proper place. And what I wanted to show as a closing point was that all of this works. And I'll just raise this up a little bit so I can keep my finger out of it and demonstrate. There's the motor turning and works in both directions. If I reverse the direction, it's back the other way. So the reason why I wanted to show that is because there are still electrical issues, even though all of the motor electronics are conducting and everything's working fine. There's a problem. I'll get this clip out of the way and I'll show you. And I'll have to, I'm not going to tackle this in this episode anymore. This is conclusion of the episode was to repair and reassemble the locomotive. So that's been accomplished, but I really would have liked to have seen it run correctly. And sadly, there's something of a mechanical nature from trying to make contact through the track. Like I can make the motor run successfully by clipping on, as I just showed you, but this does not operate on two rails yet. So in this upcoming video, I'm going to show you how I'll be careful what I say. I will show what I attempt to do in order to get this locomotive back to operating correctly. So we don't have it quite yet, but it's coming.